Hello, I'm Opens Heart. Welcome to episode 2 of my layman's series on climate. This episode will cover the planetary climate range. We will discuss the range from the coldest planet to the hottest planet. We will discuss the 3 possible houses. I'll point out where Earth is on the scale. Then we can start to discuss what climate change and tipping points are. First, we ask, how cold can a planet be? We will start our range with a planet completely frozen. Here we have a depiction of what Earth might look like if it were completely frozen. Some have suggested that at one point in the ancient past, Earth may have been frozen from pole to pole. This would be known as snowball Earth. Once a planet is frozen, it wants to stay frozen. It is very hard to warm up from a completely frozen state. It would take a great increase of energy. But let's say we can. Let's say we can dial up the climate factors at will, slowly raising the energy and warming the planet up. What would it look like? Here is our first range of possibilities. The sun hits the planet straight on at the equator. This is the area that would warm up first. We would start to see melt ponds in this area. With enough melt ponds, our first Hadley cells are likely to start operating. As we turn up the dial, we would reach a point where this area occasionally thaws out, giving us a band of freeze-thaw. As the planet continues to warm, the freeze-thaw zone would spread away from the equator, and the equator would warm to a permanently thawed zone. There would be enough energy to start the second set of atmospheric cells. Here we have a depiction of what Mars might look like at this stage. Now, as far as we know, there's not enough water on the surface of Mars to have such glaciation, but it does give the idea of a planet thawed around the middle. Back to our progression. This final stage has pushed the frozen zones back to the polar region. The tropics are well established. In this case, the third cell is just beginning to function. It's weak but operating. Because all the examples in this range have some permanently frozen areas, they are known as ice houses, for they all contain some amount of frozen ice. That is the definition of an ice house, a planet that is at least partially frozen. Next, we enter the greenhouse zone. Here the warmer freeze-thaw zone has reached the poles. There is no longer any permanently frozen zone on the planet. Thus, I'm defining a greenhouse as one with no permanently frozen zones. In this series, the freeze-thaw zone gets pushed north until it too is non-existent. The tropical warmth spreads until we have tropics all the way to the poles. If we continue to turn up the planetary dial, we will leave the greenhouse range and enter the Hothouse Range. I am defining a hothouse as one where some part of the planet is too hot for liquid water to remain. Not that it is boiling, but that it evaporates faster than it is replenished. At the low end of the scale, the equator starts to dry out. As we move up the scale, more of the land dries out. The hot land would spread northwards like a reverse ice age. Instead of glaciers moving from the poles to the equator, we have a hot, dry wasteland expanding towards the poles. Given enough energy, the hot land could reach the poles. Water would not sit on land for very long. Venus is an example of a hothouse in extreme. It is theorized that at one point Venus had oceans, but they have long boiled off. There is no liquid water on Venus. There may be liquid lead, but not water. Notice in the last example of this hothouse range, I have drawn the Hadley cells as very large, and the second and third atmospheric cells much smaller. Actually, the Hadley cells have been increasing all along. They slowly expand as energy is added to the system. My drawings do not show this growth until the last couple of examples, but it has been going on the whole time. To illustrate this, here we have a cross-section of the atmosphere of Venus. As best we understand it, this diagram shows 2 layers of atmosphere, the outer layer and an inner layer. The outer layer circulates heat from the sunward side to the dark side. The inner layer is more relevant to our discussions. You can see there are still 3 atmospheric cells remaining in the lower atmosphere. The first cells are huge and cover most of the planet. The second and third cells are squeezed into a small area near the poles. If Mars marks one end of the range and Venus the other end, where is Earth on this scale? Earth is here, at the top end of the ice house. We have had permanent ice at the poles for a very long time now. We believe the Earth has been colder and hotter than it is now. The Ice Age represents one position colder, and fossil plants and animals as far north as the Arctic Circle represent a warmer position. Thus, the Earth has moved up and down the scale at different times in the past. The rest of the series will explain the evidence for Earth beginning one of these climatic shifts. Now, why have I gone to such lengths to lay this all out? This is why. There are people, stories, websites that are overdoing it. They are claiming that the Earth is in danger of entering a runaway state that would take it all the way up to a Venus-like hothouse. There is a long way to go from here to there. Most scientists are in agreement that the current processes at work are not sufficient to push the planet that far. Let me be clear. The Earth is not entering a runaway state that will boil the oceans off. That may happen in 1,000,000 years or more when the sun expands to a red giant, but it is not happening now. What scientists are talking about when they talk about climate change and a tipping point, they're talking about moving from this top end of an ice house to this low end of a greenhouse. Let me repeat that. This series is explaining the evidence for moving one position warmer, not running away to a Venus state. Do you see why I've gone so slow and covered so much foundational knowledge? It is to bring you to a state of understanding of our current position in the range, and to have the background to understand climate change in context. One of the hardest things about this series is holding it to exactly what is happening, no more and no less. One of my major goals for this series is to lay out this understanding of what climate change is and what it is not, to say it is this much change, no more and no less. I invite you all to stay tuned to episode 3, where we dig deeper into this planetary climate range and what a climatic shift could mean for us.